Lesson 29, Solving Literal Equations. A literal equation is an equation with more than one variable. So what we're going to have equations that have multiple variables that we're going to be working to solve here. So, for example, example 1, well, I guess I really didn't need that much room, but we'll take it anyways. Okay, example 1 wants us to solve for x. X in this equation is right here. And we're going to treat this the exact same way that we normally do whenever we're solving for x and there's nothing else but numbers there. So I'm trying to get x by itself. I'm only looking at the side that has x. The side that has x is over here. The farthest thing away is this -5, or this 5 that's being subtracted. The opposite is going to be to add 5. What I do to one side of this line, I must do to the other side. So I'm going to add 5 over here. So 5s will cancel out. Y plus 5, are those like terms? I hope that you're thinking no, because for these to be like terms, I would have to have a y with this 5, and I don't. This is a constant, this is a variable, they're not like terms. So I'm just going to write it as y plus 5. My equal sign is going to come straight down, and then I have negative 3x. Still don't have x completely by itself like I want, so I have to get x all by itself. And right now it's being multiplied by this -3, so the opposite is going to be to divide by -3. And we always say what we do to one side, we must do to the other side. So I'm going to divide this entire side by -3. And again, this shows that I did it to one side, I'm doing it to the other. So -3's will cancel, leave me with just x, which is going to be equal to, this -3 is dividing both terms, or all terms that are on this side. So in front of this y, I hope that you remember that when we don't show a coefficient, it is an understood 1. So I could show this to be -1/3 y. And then I have positive 5 over -3. Positive and a negative are opposites, so I'm going to have -5 over 3. Final answer. Example 2, we're essentially doing the exact same thing, but we're working with different variables. We're wanting to solve for r, and on both sides I have 3r plus 2s minus 7 equals -4s plus 4r minus 8. And this left side of the equal sign, I'm going to split this. The left side is as simplified as it can get because I don't have any like terms. The right side is as simplified as it can get because I don't have any like terms. So I want to get r by itself, and I want you to remember that whenever we're trying to solve for a variable, we always, if it's on both sides of the equal sign, we want to start by getting it all on the same side once we have everything simplified. So what I'm going to do is I have 3r here and I have 4r here. I'm going to move my 3r to the other side so that I have my r's all on the same side. So I'm going to take 3r minus 3r, and what I do to one side I must do to the other. Now if I have like terms, when I'm subtracting or adding, I have to keep them with its like terms. So I'm just going to stack minus 3r underneath its like term over here. Those will cancel, leaving me with 2s minus 7 equals -4s. And then I have 4r minus 3r just gets me r, or 1r, minus 8. Now I have r all by itself on one side. I want to move everything to the other side. So I can start by moving the -4s or the -8. It doesn't matter which. I'm going to move that s so that I don't have two variables over there anymore. So I'm going to have to do the opposite. This term is being subtracted, so I'm going to add 4s to both sides. So again, if I have like terms, I have to stack it underneath. So I have 2s and -7. The 4s and 2s are what are like terms here. So I'm going to stack it under its like term. Those will cancel. I have 2s plus 4s is 6s minus 7 equals r minus 8. And finally, I want to get r by itself. To do that, I need to move this 8. I'm going to add 8 to both sides. Again, I'm adding it with its like term. These are both constants, okay? So those will cancel. And remember, it is always the other side of the equal sign, just to be on the safe side there. So I'm left with r equals negative 7 plus 8 is positive 1, and I have 6s. So 6s plus 1 equals r, or r equals 6s plus 1. We have the formula C equals 5/9 times the quantity of F minus 32. Says, find the Fahrenheit temperature when the Celsius temperature is 25 degrees. So they're giving us this formula, which is converting from Fahrenheit to Celsius. But in our word problem, we know that it's 25 degrees Celsius. So I'm going to plug that in for my Celsius, which is C. So I'm going to substitute 25 where C is, equals 5/9 times the quantity of F minus 32. I wrote 39, I have no idea why. 32. Okay, I want to solve for F here. Okay, to do that, I know that 5/9 is being multiplied by this whole thing, so the opposite would be to divide by 5/9. I want you to remember that whenever we divide by a fraction, okay, the division turns to multiplication, and then we take the reciprocal. So what I'm going to do is I'm going to show multiplying by the reciprocal on both sides, because that is the same as dividing by that fraction. So on this side I'm going to divide or multiply by 9/5. So 5 and 5 will cancel, 9 and 9 will cancel. So on the right side I'm now left with just F equals 32. Excuse me for a second. Excuse me. And on the left side, this is 9/5 times 25 over 1. We should be able to see that 5 and 25 will cancel, reduce down. So I have 9 times 5, which is 45. And finally, to get F by itself, I'm just, making all kinds of mistakes here. Okay, I have F minus 32. Okay, that's supposed to be a minus sign. So I'm going to add 32 to the sides. Cancels out, so I'm left with F equals, and when I add these two together I get 77 degrees. And so what this is telling me is that when the temperature is 25 degrees Celsius, then the Fahrenheit temperature is 77 degrees Celsius. Those are equal to each other. The formula for the area of a rectangle is A equals LW, which we know to be L equals length times width. If a rectangle's area measures 64 square centimeters and the width measures 16 centimeters, what is the measure of the length of the rectangle? This is similar, we've talked about this with squares. Okay, we're always going to write out that formula that they're giving us. And then whenever we're talking about a rectangle, it's always beneficial to just go ahead and draw that rectangle. Okay, so I know that the area of this rectangle is 64 square centimeters. And I know that in the width it says measures 16 centimeters. But I don't know what the length is. It's wanting me to find that. So I'm going to plug what I know from my picture into my formula. So I know that the area is 64 equals L is what I'm looking for. I don't know L here, so I'm just going to put L times my W, which I know my width to be 16. Okay, so L is being multiplied by 16. I want to find L, so to get L by itself, I'm going to divide by 16 on both sides. Okay, give myself a little room here. So I'm left on the right side with just L, which is my length and what I'm looking for. And 64 divided by 16 is going to get me 4. And I need to make sure that I label that centimeters. Final answer. Last example here. We're talking right now about the dirt formula, D equals RT. That is distance equals rate times time. We'll use that a lot. It'll help us solve all kinds of things. It says a family is taking a camping trip. They live 176 miles from the campsite. If they travel 55 miles per hour, how long will it take them to reach the campsite? So we know that we're working with D equals RT. Well, where D is our distance, R is our rate, and T is our time. Okay. So from the problem, it says that they live 176 miles from the campsite. So 176 miles, would that be a distance, a rate, or a time? I hope that you're thinking a distance because miles is describing a distance. So I have 176, which I'm going to plug in for D, equals, I now have R and T left. Says if they travel 55 miles per hour, 55 miles per hour, would that be a rate or a time? Again, I hope you're thinking rate because it's talking about how far it will go in a certain amount of time, which is its rate. So I'm going to put 55 in for R. And it wants to know how long it's going to take. Well, how long it's going to take is the time. So I'm looking for T. Again, I'm going to use my inverse operations to help me figure this out. So I'm going to divide by 55 on both sides because these are being multiplied. What I do to one side of the equal sign, I must do to the other. So 55 and 55 will cancel, leaving me with T. And 176 divided by 55 gives me 3.2, which is hours. Final answer. That's it for tonight. I hope that you have taken good notes, and I will see you in class tomorrow.